Most candidates walk into an MLOps interview ready to draw a perfect diagram from memory. They believe the answer lies in recalling the standard architecture for a machine learning pipeline. But here is the harsh reality. Interviewers do not care if you can recite a textbook diagram. They are waiting to see if you can defend your choices when the constraints change. If you cannot explain why you picked one component over another, you will fail the follow-up questions that trap you in a static drawing. By the end of this video, you will learn how to shift the entire narrative from rote memorization to a dynamic defense of your architectural decisions. The biggest mistake junior engineers make is treating system design as a drawing exercise. They spend hours memorizing the boxes and arrows for a feature store, a model registry, and a CI/CD pipeline. They think if they can draw the diagram perfectly, they have won. This approach fails because every real-world problem has unique constraints. A system designed for a high-frequency trading firm looks nothing like a system for a recommendation engine on a blog. The interviewer knows this. They will throw a constraint at you, like a strict latency requirement or a limited budget, and watch to see if you can adapt your diagram on the fly. If you only know one diagram, you have no flexibility. You are stuck. To navigate this, you must stop thinking about what the diagram looks like and start thinking about the failure modes of the system. Every architecture has a point of failure. In machine learning, the most dangerous failure is not a server crash. It is a silent degradation of the model. This happens when the system keeps running, but the predictions slowly become worse and worse without anyone noticing. This brings us to the critical distinction between two types of drift: data drift and model drift. These sound similar, but they require completely different engineering responses. Data drift occurs when the input data changes distribution. Imagine you trained a model to predict house prices using data from 2019. Suddenly, the market shifts, and the input features look completely different in 2024. The pipeline is still ingesting data, but the statistics have shifted. This is a pipeline ingestion issue. The root cause is the data itself. To handle this, you need monitoring that tracks the distribution of your features. You use metrics like the Population Stability Index or the Kullback-Leibler divergence. When these metrics spike, you trigger a retraining pipeline. The solution is to refresh the training data and rebuild the model. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Model drift is different. This happens when the relationship between the inputs and the outputs changes. The data might look the same, but the underlying concept has shifted. Perhaps a new tax law changed how house prices are calculated, so the old model is now wrong even though the input numbers look normal. This is a performance degradation issue. You cannot solve this by just retraining on old data. You need to validate against ground truth labels. The solution involves A/B testing or shadow mode validation. You run the new model alongside the old one to see which one performs better before switching traffic. Here is the thing that separates a good engineer from a great one. You must prioritize the latency of your feedback loop over theoretical model accuracy. In an interview, you might be tempted to propose a complex online learning system that updates the model every second. But you need to argue for a batch retraining architecture, like a T+1 system, for most use cases. Why? Because online learning introduces massive engineering complexity and risk. You must justify your choice based on the business cost. If a false negative costs the company $1 million, you might need online learning. If the cost is low, you stick with batch processing. The constraint dictates the architecture, not the other way around. This leads to the most valuable insight you can bring to an interview. You must frame your system design around the failure modes of the monitoring layer itself. What happens when your monitoring tool drifts? What if the metrics you use to detect drift are themselves unreliable? A standard diagram often ignores this. It assumes the monitoring layer is perfect. But in production, it is not. To defend against this, you need to articulate the inclusion of canary deployments or a human-in-the-loop fallback. These are your primary safeguards against silent degradation. Let me show you how to map this logic to concrete infrastructure. When you see a spike in feature drift, you do not just say, retrain. You explain that this triggers a specific data lineage alert. The system checks the source of the data, verifies the schema, and then initiates a rollback mechanism if the data is corrupt. In contrast, when you detect concept drift, you trigger a model version comparison. You pull the last known good version from the model registry and compare performance metrics. This proves you understand the operational workflow, not just the theory. You are connecting abstract metrics to specific tools like feature stores and registries. The final piece of this puzzle is understanding when to scale complexity. You should frame your system design around the organization's ability to handle operational overhead. A monolithic architecture might work fine for a small team. A microservices, MLOps architecture is necessary for a large enterprise. But you must argue that simpler is better until the frequency of drift exceeds a specific threshold. Do not propose a complex distributed system if a simple batch pipeline will do. This shows you are pragmatic and cost-aware. It shows you are thinking like an engineer who cares about the business, not just the code. When you walk into that interview, do not start by drawing a box. Start by asking about the constraints. Ask about the cost of a false negative. Ask about the latency requirements. Ask about the data quality. Then, build your answer around those constraints. Explain why you chose a specific monitoring metric. Explain why you picked a batch retraining strategy over online learning. Explain how you handle the case where the monitoring tool fails. This is how you shift the narrative. You are not just presenting a diagram, you are defending a set of decisions that balance accuracy, cost, and reliability. This approach demonstrates that you are flexible. It shows you can navigate trade-offs. It proves you understand that there is no single perfect architecture, only the right architecture for a specific set of constraints. By focusing on the thinking process and the defense of choices, you move from being a candidate who memorized a diagram to an engineer who can design a system that survives in the real world. That is the difference between getting the job and getting stuck in a follow-up question you cannot answer. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.